to trigonometry. Now we will be moving to trigonometry. Trigonometry. As the name mentions, it is connected with triangle. It is connected with triangle. So, in case of plane geometry, with respect to similar triangles, we know one point that if two triangles are similar or if two triangles are equiangular, then their sides are proportional. So, what it implies, if you take this particular figure or if we consider this particular figure by drawing different perpendiculars here, whatever the triangles are formed, they are all similar. They are all similar. What that similarity implies? The sides are proportional. The sides are proportional. See, even though if you consider these two triangles where the lengths of sides are different, but the ratios are constant. So, the ratios are constant. So, the ratios connected with the same triangles, the ratio of the sides is independent of the length of the sides, and it depends on the angle, and it constitutes the principle of trigonometry. So, now consider a right angled triangle. Consider a right angled triangle ABC. So, now we will be considering a right angled triangle ABC. So, this is A, this is B, this is C. It can be denoted by theta. It can be denoted by theta. So, now here we will come across the ratios of the sides. Say here one ratio is AB upon AC, one ratio is BC upon AC, one ratio is AB upon BC, and then you can take their reciprocals. So, how many ratios we can have? We will be having only 6 ratios. Only 6 ratios. So, what those 6 ratios of the sides? Which are those ratios? One is AB upon AC, and another one is AC upon AB. One is BC upon AC, and then AC upon BC, and third one is AB upon BC, and last one is that is BC upon AB. So, 1, 2, 3. Totally how many ratios we will get? We will get only 6 ratios and not more than 6 or less than 6. See, as it is mentioned, these particular ratios are independent of the lengths of the sides. So, even though you change the length of the sides in this fashion, the ratios will not change. The ratios will not change. When the ratio will change? When the angle changes. When the angle changes. So, the ratio of a side of the ratio of sides of a triangle, it depends on the angle and not on the lengths of the sides. So, what we can say? This particular ratio is directly proportional to angle. Or what we can say? It is a function of theta. What we will say? Function of theta. What we say? Function of theta implies, see, function of theta is equal to ratio. So, it is the principle of trigonometry. So, how many ratios will be there? That number of functions will be with us. How many ratios will be there? That number of functions will be this. So, with respect to theta, if this particular theta changes, automatically the ratios will change. So, all the ratios are functions of theta. How many ratios are there? There are 6 ratios. Therefore, there are 6 trigonometric functions only. Instead of representing those particular functions by these letters f theta, g theta, h theta, phi theta, like that, we can give specific names to them. Connected with the ratios. connected with the ratios. Symbolically, with respect to theta, this AB can be written as either opposite side or perpendicular. This can be written as adjacent side or it can be taken as base, and this is always taken as hypotenuse or hypotenuse. So, connected with this theta, instead of writing ABBC, which will be for a specific triangle, what we can say, opposite side to hypotenuse is one ratio, hypotenuse to opposite is another ratio, adjacent to hypotenuse is one ratio, hypotenuse to adjacent is another ratio, opposite to adjacent is one ratio, and adjacent to opposite is one more ratio. So, these 6 ratios constitute 6 trigonometric functions, or these are the functions of theta, the principle of trigonometry. So, now accordingly we will be naming them. The ratio of opposite side to hypotenuse is a function of theta, and the name of that particular function is sine. So, what we can write here, sine theta is what? It is equal to, see, opposite side upon hypotenuse, or you can say perpendicular upon hypotenuse, or symbolically what we can say, AB upon AC. AB upon AC. See, this one is reciprocal and this is known as secant of theta, we will come to afterwards. And then now we can take co of this ratio, that is cosine of theta. Cosine means co-side of that particular perpendicular, and what it is? It is nothing but adjacent side. It is nothing but adjacent side upon hypotenuse, or what we can say, base upon hypotenuse, or accordingly that is BC upon AC. BC upon AC. Then we will be having one more function, that is called tangent of the theta. And what this particular tangent of theta is, that is opposite side upon adjacent side, opposite side upon adjacent side, and that is equal to, opposite side is known as perpendicular and it is known as base, and that is equal to AB by BC. So, if you take their reciprocals, reciprocal of sine function is cosec function, reciprocal of cosine is secant function, and reciprocal of tangent function is cotangent function, and we can write them afterwards. So, now to remember these particular conventions, or to remember this particular trigonometric definition, we can go through this particular slogan. What the slogan is? Some people have curly black hair through proper brushing. So, what it implies? Sin theta is equal to perpendicular upon hypotenuse, cos theta is equal to base upon hypotenuse, and tan theta is equal to perpendicular upon base. So, this is the definition of basic trigonometric functions and their reciprocals. What we can say, cotangent of theta is equal to adjacent side upon opposite side, and that is nothing but BC by AB, and then secant theta, secant of theta is equal to what it is, that is hypotenuse upon adjacent side, and that is nothing but AC upon BC, and then finally cosecant theta, that is cosecant theta is equal to that is hypotenuse upon opposite side, and that is nothing but AC upon AB. So these are the basic definitions of 6 trigonometric functions, but however we cannot write down all these particular letters here, and so we finally shortcut them. Sin theta is SINE, it is only written as SIN. Here we will be writing cos theta COS only. Here we will be taking tan theta, and here we will be taking cot theta, and here it is taken as sec theta, and finally it is taken as cosec theta. So this is introduction to trigonometry and trigonometric functions. So thus finally you can write down in a list. So therefore standard results. What you can go through? Standard results. So first one is sin theta into cosec theta is equal to that is AB upon AC into AC upon AB is equal to that is 1. Second one, cos theta into sec theta is equal to BC upon AC into AC upon BC, that is equal to 1. And third one is tan theta into cot theta is equal to AB by BC into BC by AB, that is equal to 1. And similarly you can write down one more formula, that is tan theta is equal to sin theta by cos theta sin theta by cos theta, and cot theta is equal to cos theta by sin theta. So these are the basic standard results according to this particular triangle. A, B, C, and this is theta. With respect to theta, this is opposite side, and this is hypotenuse, and this is adjacent side. So this is for the day.